Few things draw my attention like a looming deadline. Some part of my brain watches in morbid fascination as the deadline approaches, wondering whether to call emergency services or maybe just settle in, make popcorn, and watch the show. I can't help but keep a wary eye on it, a wary eye that is no longer paying attention to the code at hand. I need all the wary eyes I can get. Without them, forget best practices. I revert to less sophisticated problem-solving strategies like guessing and desperately copying code off of Stack Overflow. Sometimes I'm happy. There are moments when the world melts away, your sense of self dissipates, you become completely absorbed in what you're doing. Time appears to slow down and speed up simultaneously. Being awesome feels effortless. I've taken to coming into the office early in the morning and committing random acts of refactoring. Some people are calling this guilt-driven development. But really, it's not. Refactoring just makes me happy. And more refactoring is an optimization. So today, I'm going to tell you a story. The arrow needs to point this way because it's a refactoring story. Anyway, it has a beginning, two middles, and an end, and a moral. To be clear, when I say refactoring, I mean small, careful, controlled steps that improve the structure and the readability of the code without changing its behavior. Tests are implied. So, once upon a time, there was an application that performed some incredibly dirty hacks in order to deliver data straight into a number of real-world, old-school, hard-copy publishing systems. I found this particular specimen in the dark recesses of that code base in a module that was 300 or so lines long, most of which was in a single method. This module talked to code all over the application. It dealt in temporary files, FTP, it shelled out, it used exif2 to write metadata into JPEG files, it handled encoding. It had a comment in it that read, "A kitten dies every time this code is run." We had it running on a cron job. It had no tests, nor was there any documentation. This is essentially a bucket of business logic. It jumps through hoops in order to name files so that they end up where they need to be. There is a comment, but it's almost as bad as the code. Also, it's wrong. The input to the method is target, which is the God object in the application. It's an active record model, and that class is well over 500 lines long. The big picture here is that information is being shoved onto a string in order to build up a file name. And there is a bit of code here that's not actually shoveling things onto a string, and this draws the eye. It appears to be a chunk of something, and is probably a good candidate for extraction. Another striking aspect of the code is that it's littered with a bunch of low-level details. Now, it makes it harder to see what's going on, but amidst all that clutter, there does seem to be chunks that could probably be named. So what are we looking at? We're dealing with a very large method. It appears to be doing things at two different levels of abstraction, and nothing at the lower level of abstraction is being named. These are not characteristics of good code. So the thing to do with big, ugly code is to break it down into small, ugly code. There's a critical difference between breaking code down and breaking code, which is why the first middle of the refactoring story is all about adding characterization tests for the method, and then the second middle is the actual refactoring. Where do you even begin testing something like this? We don't really know what the inputs look like. We certainly don't know what the output looks like. We do know that it's in production, and it appears to be working because we haven't had any complaints from the customer about it. The easiest way to discover inputs is to just send something, anything really, into the method and then see what comes back out. We need an assertion to work against, and again, it doesn't matter what that assertion is, because it's going to be wrong. So the nice thing about being wrong is it tells you what right looks like. So running this fails, obviously. And the error message helpfully tells us that we're missing an input. It also points us to the exact spot in the code where this is happening. And what we find there on line 6 comes as no surprise at this point. The message, publish on, is being sent to target. It returns a date. So meanwhile, back in our tests, we know that the stub represents a target, and we're ready to start fleshing out the inputs. The one we need right now is publish on, which we know is a date, and the failure tells us what our next input is. Digging around in the code reveals that XYZ category prefix is a string. And next we have kind, which is also a string. Personal is a Boolean. ID is an integer. And title is a string. And this gives us our first real failure, meaning that we've gotten all the inputs right. These are the inputs. These are the messages we need to send to target in order to build up a file name. And with the inputs in place, we're also given the output, which looks like this. And now all that practice copying and pasting from Stack Overflow comes in handy. Copy the string from the failure into the assertion, and the test should pass. It doesn't. Due to random characters. Now, the fix for this is to use a regex, which gives us our first passing test. We're not quite done yet. There are a bunch of low-level details that aren't being exercised, and there are alternate paths through the method. So we need to improve the inputs for these 3 lines of code, and then add test cases for the lines that have conditionals in them. At every step, failing tests tell us how to tweak our assertions. These are trivial to fix and boring to watch, so I'll show you some highlights. Publish on. Publish on gets 0 padded, but pi doesn't get affected by this, so we're going to fall back to E. Kind G subs out underscores, so we need an underscore, so we can see it being removed. Title. Now, title appears to strip out everything, and the existing input has very little cruft in it. We need a number, some funky characters, an uppercase letter. There's something really fishy about that regex. What's with the square brackets? Now, I'm too lazy to reason about this, so I'm adding a test case, overriding the stub's input for title to give it some square brackets, and this proves that indeed square brackets get left in place, which is most likely not the intended behavior. The test serves as documentation until we can clarify with the customer. The first conditional deals in personalization, and our stub doesn't personalize, so we're going to need a test for the case that does. And we're informed about yet another input that's missing, which is trivial to supply. And the other conditional on that line of code provides a fallback in case age is nil. And the test for this stubs out the same inputs as the previous one. And the final conditional is a ternary statement that's trying to determine where to truncate the target's title. Our default input for title is neither long nor short. So we can make it longer to make sure it gets truncated, and then we need a test case for the case where the title is too short to get truncated. And at this point, we have protection against regressions. So what have we actually accomplished so far? We took a completely untested, undocumented piece of code, and with a bit of hand-waving, we got fake assertions to give us the inputs. The inputs gave us the outputs, and the outputs gave us the real assertions. That's almost karmic. Then we had to reason about the code. We inspected every line to find pieces of input that would actually exercise it, and we made sure that every branch of every conditional was being called from a test. The tests themselves are not providing a specification. There is no design being done here. What we're getting is a safety net. The biggest win at this point is that we can start changing things without breaking into a cold sweat. Here's what we're going to do. We're going to isolate the method into its own class, and then we're going to extract a bunch of smaller methods. I'm going to borrow a detailed prescription from Martin Fowler's book, Refactoring, called Replace Method with Method Object. Now, traditionally, you do this if you have a big computation, a bunch of temporary variables, and you don't want to be passing those temporary variables around to the methods that you're extracting. First of all, we need to make a home for the code, add an initializer that takes the target, add an attribute for it, and then just copy-paste the whole thing in there. The method shouldn't be called on the class. It definitely needs a better name, and it no longer takes any arguments. So back in the old module, we need to reference the new method from the old one, so just delete the whole body of the method, reference the new file, instantiate the class, pass in the target, call name on it, and we're green again, which means that we have a license to go to town on this code. Where to begin? Honestly, you could start anywhere. I really like deleting stuff, so let's get rid of that comment. And now, somewhat arbitrarily, I'm going to go from biggest to smallest. So the biggest chunk that we've seen for extraction is the truncated title bit. The actual mechanics of extracting a method are as follows. Create an empty method and name it by what it does or what it is, not how it does it. Coming up with a good name is often the hardest thing you'll ever do in a refactoring. The next step is to copy the lines of code from the source method into the new one, and then scan the new method for local variables. Final name is declared in the source method. So we have a choice to make. Either do the mutation here, which means that we need to pass the file name or name in or make it an instance variable, or we could make this a query method. Now, the whole point of the refactoring is to separate out the two different levels of abstraction, where we build up the file name in one place and I'll put together all the little pieces somewhere else. So we're going to just return the value that we need. And the other temporary variables are all local to this method. Now we need to assign the result of our query method and delete the temporary variables that are no longer used in the source method. And then we're green again. Before we move on, I'd like to tidy this up a bit. There's some unnecessary work going on in the regex. We're doing a case-insensitive match, and then we're downcasing. There's something that drives me nuts in the match if brackets. The spurious parentheses have got to go. Another thing that bugs me is the fact that we have a ternary statement to determine the range for a match if. Now, a match if isn't going to raise an exception if you try to truncate a 4-character string to 9 characters. It's just going to give you those 4 characters. So the ternary statement can go. Since we no longer need truncate to, we don't have to worry about the length of the title, so that can go too. And with those two lines gone, there seems very little point in having a temporary variable, so we can ditch that as well, effectively leaving us with a single line of code in truncated title. The longest line is now the hex digest stuff. Hex digest is a terrible name in this context. Noise seems appropriate. Copy stuff in, assign the result, and we're green again. And personalization is now the longest. Perform a quick extraction, publication day, and XYZ category prefix. So inside this class, XYZ is redundant. The fact that it has a prefix is irrelevant, so we can drop the XYZ prefix as well as the prefix suffix and just call the new method category. And then there's kind. And this leaves us with a fairly readable method. And we could totally leave it at this. There's still some spurious stuff in here. So take publication day, for instance. Publication day returns a string. So why are we interpolating it? The same goes for category and kind. Now, target ID is an integer, but string interpolation is going to turn it into a string anyway. And now the next move might seem a little bit more subtle. There's a kid's game called Spot the Differences or Find the Differences. Look at this and then think about what pieces are different from the others. All the file name pieces are being shoveled onto the string except the first one. So if we start off with an empty string, we can make the first piece just like all the others, up to a point. The extension is not so much like the others. So if you conceptually separate this into two jobs, build up the actual file name, and then slap the extension on it, then we're left with two distinct sections, one where everything is smushed together, and the other where the pieces are separated by underscores. If we extract the smushed together pieces into a method, then all the remaining pieces can be separated by underscores. And we can now shovel them into an array rather than a string, which gets rid of much more of that interpolation syntax. Just join them in with an underscore. There. Done. Is it perfect? Of course not. Is it better? Hell yeah. We went from this to this in less than 30 steps. Let me just show you that again. Before, after, before, after. First, we quarantined the method, then we extracted stuff. Extracting stuff basically boils down to identifying a piece of code that performs a subtask and then giving that code a name. Well, back when we started out, we identified 3 issues in the code. We had a large method, we had 2 different levels of abstraction, we had unnamed abstractions. And extracting methods addressed all 3 of those issues. Having done that, we still had some ragged edges. So we kind of picked through the code and polished it up a little. That was the second middle of the refactoring story. I'm going to conclude by taking a closer look at pointless cruft. In the field of information design, there's a term chart junk that refers to visual elements in charts and graphs that refer to noise, superfluous elements. They don't help you understand the data. They often get in the way of comprehension. To give you an idea of what we're talking about, this graph gets just about everything wrong. This is the exact same data presented without chart junk. Code junk is the Ruby equivalent of chart junk. Now, this isn't about coding practices. It's not about dry and SRP and naming things and small methods. It's purely about noise. So I've tried to classify code junk and came up with this list. Number 10. Does a bear shit in the woods? Comments shouldn't echo the implementation. They shouldn't be wrong. They shouldn't be imprecise. And they should not be misspelled. 9. It is my conviction that everybody should make their editor show them trailing white space. If you leave it in, you have noise in your code. Then when you take it out, you get noise in your diffs. I don't have the social skills to tell you this in a diplomatic manner. Shove your white space where the sun don't shine. 8. If it's dead, let it rest in peace. What were you saving it for anyway? You need to learn to let go. And this? What's it doing in source control? 7. If you do this, I will come to your house and take your keyboard away. What's your excuse? This is vile. When I see this, I secretly wonder if you don't wash your hands after you go to the bathroom. 6. Some code changes nothing. We have intelligent defaults for a reason. Don't do this. I love this. Good old-fashioned closing the barn door after all the animals took off. 5, let's talk about dependencies. In particular, dependencies that you're not actually depending on. This may or may not impact performance. It probably will impact the performance of your tests. That's a different story. Mostly, you just added noise to your code. 4, how to say no and really mean it. This is a true fact. I've got another true fact for you. 3, don't do work that the computer is already doing for you. You'll recognize this. Not to beat a dead horse, but gross. More stringifying strings. This is kind of the same thing. Join will implicitly call toString on the elements of the array, so you don't need map here. Again, the match-if brackets don't need your help. We saw this in today's example. Also from today's example, the computer isn't doing the work for you here, but absolutely should be. And 2, test suites should be curated, maintained, fed, watered, coddled, and minimized. More tests doesn't mean more certainty. Doesn't mean it's more correct. Now, there is an exception, and it's if documenting behavior outweighs the cost. Choose wisely. Now, I haven't actually made up my mind with, which side of the fence this example falls on. I'd probably say this is code junk. Finally, the compounding sin. You know the old saying, 1 + 1 = 3 for very large values of 1? This is revolting. In fact, it bears a horrifying resemblance to the code that we just refactored. When people say that software is grown, not built, I'm pretty certain that this is what they're referring to. It's a bit like fungus. So earlier I said about the refactoring that after we quarantined the method and extracted stuff, then we kind of polished up the code a little. I'd like to restate that in light of the previous section. First, we quarantined the method. Then we extracted other smaller methods. Then we eliminated code junk. All right, so that was the ending of the refactoring story. Before I get to the moral, I'd like to mention that the whole thing lives on GitHub. The refactoring was committed step by step, so if you want to look at any of the mechanics more closely or run the tests or whatever, dig through the commit history, it's all there. If you want to dig deeper into the subject of refactoring itself, there are books. This is Martin Fowler's canonical text translated into Ruby. It provides a catalog of step-by-step descriptions of actual refactorings that you can follow. It also has a list of common issues that you'll meet and maps them up to refactorings that will solve those issues. Refactoring Ruby, it looks like it might be the same book with a different cover. It's not. This is a companion to the previous one. It has exercises. So the way you read this book is you have it next to your computer and you work through all the examples. Otherwise, there's no point. You can't talk about refactoring legacy code without mentioning this book. Working Effectively with Legacy Code by Michael Feathers is a treasure trove of techniques for dealing with the special flavor of crazy that you get in legacy code bases. Now, all 3 of those books assume that you have a certain level of knowledge about arranging code in a good way. If you don't have that knowledge, I highly recommend reading this book, Practical Object-Oriented Design in Ruby, which will give you a good basis for reading those other books. All right. I have a vague recollection of the night when the code that we started out with today was written. Let me rephrase that. I vaguely recall writing it. Yeah. When I panic, I write god-awful code. Other people do yoga or meditate or go whitewater rafting. I refactor. It soothes me. Now, science, if you believe that sort of thing, actually explains why. The key player in the game is working memory. Working memory is the thing that allows you to do mental arithmetic. You store off temporary results in memory as you work other parts of the problem. And the main differentiator in performance of tasks that rely on working memory is the type of strategy you're able to apply to a problem. So people with better working memory can apply more complex and more successful strategies. Here's the deal. When you worry in ways that involve mental chatter, you use up available slots in your working memory, and you no longer have the swap space necessary to use the complex strategies, and you revert to less successful ones. This is where refactoring comes in. Refactoring makes you smarter. Refactoring essentially gives you an exobrain. A bunch of those little details that under normal circumstances go into working memory get offloaded into your tests, and once you start refactoring, you begin reclaiming your brain. It actively counteracts panic. One of the really unexpected things that happened when I started refactoring, simply for the act of refactoring itself, was that I started optimizing for happiness. I would specifically put something into its own class just so that it would load quickly. And the feedback loop that you get when you have sub-second test suites for the thing that you're working on is unbelievable. It's a huge enabler for flow. Now, flow is nice. Flow is more than nice. It's like a bliss cocktail. Selfishly isolating code in order to improve my own happiness turned out to be a pretty good deal for the code as well. Suddenly I was avoiding dependencies. I was constantly asking myself, can this be a separate class? How about a gem? What is the unrelated subproblem here? It made a dramatic difference. In summary, refactoring makes you smarter by providing you with an exobrain. It is preventative and curative with respect to panic. And if you optimize for developer happiness by making your tests really fast, you get loosely coupled code that adheres to the single responsibility principle. Thank you.
So, thanks for this closing keynote. And before I send you all off to get something to eat and welcome you back here at around 8 for a last drink with us before you're getting home or crash in your hotel room or whatever. And yes, those who subscribe for it will have you back at the boat trip to the center of Ghent tomorrow at